Alright guys, this is the beginning of chapter 9. There is a lot of odd topics that are thrown together all at once in this one flip chart. We're going to try to kind of blaze through it just so that you can see it. It is the introductions of sequences and series, factorial notation, summation notation, what a series is, such as that. I may not leave it on the screen very long for you to write down the notes. You need to know that the notes are attached to my webpage. I am going to export this flip chart to my webpage if you need them. So you can go there and you can print them out or you can copy them. They'll be saved as a PDF. So you can get them there if the video goes too fast, or you just hit the pause button. So this page gets a little small because it got lengthy there. This is the technical definition of a sequence. A sequence is where your domain is all the, see what it says, the set of positive integers. So you are replacing x with 1, 2, 3, 4, 5. So that's where your a sub 1, a sub 2, a sub 3 comes from. They get a little bit more definitive down here in the bottom where it says definition of a sequence. You need to know that an infinite sequence has no end, keeps going. Finite sequence does. It has a definitive stopping place. So that's the difference between those two. Make sure that you know that. And a finite sequence ends, an infinite sequence does not. I mean, that should make sense. Infinity keeps going and going. Okay, now, if you're looking at the beginning here, it says writing the terms of a sequence. It says write the first 4 terms of the sequence given by these formulas. And just a disclaimer here, we may or may not try all of the examples that are on the board. This one, they're just wanting you to come in and actually use your domain. Proper notation and writing things neatly is wise here. So 3 times 1 is 3, minus 2, 1. Okay, come back, a sub 2, then you're putting 2 in the place of n every time. So put a 2 there. Well, 3 times 2 is 6 now, minus 2 is 4. Okay, then come back and put a 3. 3 times 3 is, that's going to be 9 minus 2, which is 7. And we're going to come back with 4. And at this point, you've probably figured out the pattern. You could probably roll with it without writing all of this other stuff. So, because you know that's 10. Because we know, hey, we're going up by 3, go up by 3, go up. Next one's got to be 13, right? So a sub 5 is 13. If you want to write the stuff in the middle, great. But at some point on the third or the 4th term, you're probably going to figure out what this pattern is. Okay, now B is an interesting little booger, because if you do the same thing for B, it behaves a little differently. This little thing works magic. If you come in here and you put a 1 there, that is going to actually work, and I'll tell you what, let me change colors and move this thing out of the way. That's going to be 3 plus negative 1. Well, that is 2. All right, come back for a sub 2. 3 plus negative 1 squared. All right, now when I take a negative number and I raise it to an even power, I now have just a regular old positive number. So 3 plus 1, just a regular 1, that's 4. But then what happens whenever you go back and now my power is odd? When your power is odd, well, now there's 3 negatives here, and he goes back to being odd like he was in the first one, right? Well, 3 minus 1, we're back to 2. So what is this thing doing? He's bouncing, isn't he? Next one's going to be 4, and he's going to be 2, 4, 2, 4, 2, 4, 2, 4. This thing works magic. So this negative 1 to the n power, what it does is it alternates. You see what it did here? You have the alternation of signs. Now, the only thing you have to watch for, if you're ever trying to manipulate things, is do you want to start with a negative number or do you want to start with a positive number? Because if you need it the other way, you might want to take it and do negative 1 to the n plus 1, or you could do negative 1 to the n minus 1. Both of those would, instead of starting with a negative number, you'd start positive. And then you would go negative, positive. So it's just a different variation on it. You kind of have to play around with it and see which one you need. All right, so same type question. Go and write the first 5 terms of the sequence given by this. Well, hey, there's the magic right there at the top. If you did a sub 1, we've got negative 1 to the 1, 2 times 1 plus 1. We know that's a negative 1, and that's going to be 2 plus 1, so negative 1 over 3. Come down here, put in a 2. Alright, oops, I need my 2 right there, don't I? Okay, so that's going to be a positive 1, and then that's going to be 4 plus 1. So I have positive 1 over 5. Okay, then I've got negative 1 to the third. That's going to be 2 times 3 plus 1. Well, that's negative 1. That's 6 plus 1. Have you picked up on the pattern yet? What's the top doing? The top is alternating signs. The bottom is odd numbers. So there's your first 4 terms. You could do the 5th one if you wanted. It asked for 5, so you'd need to do the 5th one, but we're trying to get done. So, okay, now this is an interesting little talent that you can work up. Later on, when we cover the sections for arithmetic sequences and geometric sequences and such as that, we're going to find definitive ways to come up with your A sub n formulas. There are structured methods for it. Right now, it's just a trial and error thing. Hey, can you come up with an equation? Because right now, we need to start by putting in a 1 and come out with a 1. You know that you're skipping, it's going up by 2 every time. Well, that's 2n, 2 times n. But if I just put in a 1, now I get a 2. And when I put in 2, I get a 2. I'll take it down by 1. So, if you see what I mean, if I put in 2 times 1, that's going to be 2 minus 1 is 1. And then I can do, put in a 2, it's going to be 4 minus 1 is 3. And you can keep going. So that's going to be, oh, I skipped one, didn't I? Ooh, I don't know where I got that from. So 2 times 3 is 6 minus 1, there's your 5. So that one works. This one is a little bit more irritating. You do have to alternate signs. Well, we figured out earlier that the magic thing to alternate signs is the negative 1 to a power. Then you have to kind of look at your numbers, what's going on with them. And it's going to take you a little while to investigate, but what you really have here, if you look, this is 1 plus 1, this is 4 plus 1. And I'm not paying attention to the positive negative, okay? So don't get up in arms about that. I'm disregarding the positive negatives because this little booger is going to take care of that for me. So 2 is 1 plus 1, 5 is 4 plus 1, 10 is 9 plus 1, and 17 is 16 plus 1. Do you recognize what's going on with these first terms? I hope so, because all that is n squared plus 1. And I'm needing to alternate signs. So I need that. But there's an issue. Because if you just did that and you put in a 1, if you put 1 squared plus 1, and you came over here at negative 1 to the 1, that's going to be 2. And this over here is going to be negative 1. 2 times negative 1 is a negative 2. So if you look, I have the wrong sign. If you remember earlier what I was saying, if you need to manipulate the sign, we need to make it the other one. So come in here and do a plus 1. So if we put a plus 1, what that's going to do is this is going to change. Now that I put a 1 in, 1 plus 1 is 2. Oh, whenever I square a negative number, I get a positive now, and I get the positive match. This is perfect. So make sure that you verify that your signs work correctly if you're having to do that. Okay, next topic, recursive formulas. Recursive formulas build on themselves. Basically, you take the previous terms and you work with them. So Fibonacci sequence is the most famous sequence, recursive sequence of all. Your first term, and they did call it a sub 0, is 1. And then a sub 1 is 1. Now, this is where it gets defined recursively, okay? Think about it. A sub k, to get that, you take a sub k minus 2. That means go back 2. So this right here is referring back to this one. And then this one says you want to go back to k minus 1. Well, he's going back to this one. This is if we're looking for a sub 2, all right? What is it telling you to do to them? I kind of covered it up, didn't I? It's saying add them. So if you're wanting the next term, you're doing 1 plus 1. So a sub 2 would be 2. So we've got 1, 1, 2. And then whenever you go to a sub 3, it's going to say, hey, take the previous 2 and add them. And then when you go to the next one, it's going to say, hey, take the previous 2 and add them. And the same thing every time. Take the previous 2 and add them. That's recursive, okay? It builds on itself. Now, the definition of it kind of looks a little awkward, so it's going to have this little subtraction in the subscripts, but that's telling you to go back to the previous terms, pick that up, and then it'll tell you what to do to them. Here it's saying add these two terms together. You might come into context with one that says something like a sub k equals a sub k minus 1, and it might say plus 5. So it might say, hey, add 5 every time. Okay, so totally different topic, completely different. Factorial notation. Factorial notation, and I copied this out of the book, and I'm not real thrilled with it because this is not the way I was taught how to write factorial notation. Whichever number they tell you, that's what you start with, and you just go down from there. You break it down until you get to 1, but it's the product of all of those terms or digits. So basically, if I'm telling you 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So whatever this number is, you write it here, and then you just start multiplying all the way down, okay? The only thing that's really necessary that make sure that you get off of this page, because we really don't have to go through all this let's practice business. Make sure that you understand that 0 factorial, that is a special case, that is considered 1, okay? There's really not a whole lot to expand on, like the first 3 over here. 0 factorial, that's 1. 1 factorial, there's no expansion, it's just 1. 2 factorial, well that's 2 times 1, that's just 2. Those are kind of lame. Once you get beyond that, then you have to start thinking. But 0, 1, and 2, that's not too bad. So let's actually use it. Okay, I'll tell you what. This is what we really need right here. If we're going to evaluate something and reduce factorials, I'll tell you what, we're running out of time, so let me catch you in the next video and I'll show you how to do these, okay? So I will catch you on the next one.